So, hi, we're going to balance reactions now. Now, balancing reactions is something that some people, like I said, this is the thing I was saying where some people can think back to chemistry class from like a long time ago and be like, oh yeah, I didn't like balancing reactions. So just be aware of that. This can be challenging for some people. Like half of you, this is just going to be like, yep, I totally get this and it makes sense and you're good without any issue. The other half of you, you might struggle a little bit, and then and there'll be some of you that this is just not intuitive, and you struggle with it, and that's okay. Don't be upset or bothered by that fact. It's not intended to be super hard. It's just something that you got to practice, and it's a skill. Once you practice it, once you do it, you'll be fine. All right. So, first thing, why do we balance reactions, and like what am I even talking about here? Well, when you have a chemical reaction. So let's go back to an example that we did previously where we said that, so it was the hydrogen gas one. So let's say you have H2 plus F2 and it made HF. So that was a reaction I showed you, you did on your worksheet. And when you see this, you're like, okay, well, there's two hydrogens here, there's two fluorines here. And then there's this little arrow that's like, so you got to think of the reactions as like, pretend like the arrow is kind of like this major, it's like a wall. I mean, you'll later realize that there's reactions that can move forward and backwards, and there should be another arrow pointing in the other direction. But for right now, let's pretend that there's this wall. So over here, over on this side, all right, you've got two hydrogens. You've got two fluorines. We can agree on that, right? H2, F2. There's two of each. And this is the reactants. This is like the before. This is the before. This is the beginning. This is the end. In the products, the end. You only got one of each. There's like one H. There's one F. And you're like, well, wait a minute. Where did the other H go? Where did the other F go? Because there was two of each. What happened? How did this? What's the deal? And that's the point. Like, this doesn't make sense. This physically doesn't make sense if you think about the world. Like, you can't create matter. You can't destroy matter. It can't disappear. You can't just like wave an atom out of existence. You can't just be like, oh, this hydrogen, you're gone, goodbye, disappear forever. And not just like from this earth, but like from the universe, existence, like it's gone. Like it doesn't happen. It's not possible. So instead, there's this thing called the law of conservation of mass. So chemical reactions, when written out, must observe the law of conservation of mass, meaning that the number of atoms that you have on one side that you start with, you got to end with on the other side. So if you start with two H's on this side, you got to end with two H's on this side. If you start with two F's, you got to end with two F's. It's just that simple. So the way you do this, you just are going to be putting these things called coefficients. So it's up to you to pretty much determine, like, okay, like, how do I balance these? How do I make this reaction observe the law of conservation of mass? Now, what that means, what simple terms of this means for you, is that you will have the option in every reaction of pretending that there is like a blank space in front of every compound in the reaction, and just in front of the compounds. Okay, so make sure you understand, like, you can never ever put something in the middle of a compound or at the end. You're only putting big numbers, they're called coefficients, in front of different reactants and products. That's it. So in this case, it's like, all right, we got it. And this is just to show you the basic concept. We'll do specific examples and stuff in a little while. But basically, it's like, oh, there's two H's, there's two F's, and like, well, over here you need this to match. So what you do, you put a big 2 in front of it, and that big 2 then gets distributed to the H and the F. So all of a sudden you're like, all right, now there's two H's, now there's two F's, and you're like, okay, this reaction observes the law of conservation of mass. And it makes sense if you think about it in terms of like the actual rearrangement of the atoms itself, because then you can think and say, like, okay, I've got two hydrogens, I've got two fluorines. Well, basically what this is saying, if you want to sort of think about it, we'll do it down here. So it's basically like saying you got H bonded to H and F bonded to F. All right, and then these things react together. All right. So the way it's going to work, this bond is going to break, and you're going to have an H and an F come together to make HF. Cool. Then you're like, wait a minute. What about the other one? Well, same idea. The H and the F come together to make another HF. So that's like where the atoms actually go. The way we just write it is just simply by saying, like we say there's H2, there's F2, and that produces 2. So you get 2 of these molecules that are made. And that's how you write. And so instead of writing HF plus HF, you just write 2HF. All right. That's the basic idea. That's the basic concept of like coefficients and stuff. So that's this. In the notes, you'll notice. So in the notes, there's like this long paragraph thing. I put it down in the notes always just so you can have it. Do I think that you should follow this? I mean, it might help. I don't know. It might help to see it written out. There's 100 other explanations out there if you want to find other ones too. I'm not a big. This is not really a big like notes thing though. This is like a doing thing. Like you just go. You got to problem solve this one. That's how I usually say you do it. This slide is an explanation of coefficients. It's on there. You can read it. It's pretty much saying just what I just said. And yeah, so what I'm going to do, I'm going to walk you through and do one example here on this directly, but then this link in the notes, it's like a 20-minute YouTube video showing how to do a ton of examples on these. I strongly encourage you to watch it. If this makes sense, cool, you're good. Great, then you can honestly probably do most of these. If it doesn't make sense though, you're going to want to watch a bunch of examples. All right, you're just going to want to. And the more you practice it, the more you'll be able to do. And it'll make sense. And we'll go over this a lot. This is not a one-day thing. This is a multi-day thing. You're going to have plenty of time on this. All right, so don't freak out about it if it seems hard. All right, the way we're going to do this, let's envision that we have this equation. The way I like to do it, I like to split equations. So I like to actually draw a line down here, and there's a lot of ways you can do this, but if this makes sense, then there's a fast way you can do it in your head, which you'll sort of pick up on your own. But I like to, if I'm going to take my time to do this, then this is how I would do it. And the next thing I do then, I write out the elements that I have. So I have like 1 magnesium and then oxygen. How many oxygens do I have? I have 2. So I have 1 magnesium, 2 oxygens. Reasonably simple. This is like a super easy example. And then over here, it's like, okay, I've got, again, 1 magnesium, but in this case, only 1 oxygen. Now, these phases, the solids and the gases and the liquids and all that, those don't matter at all. So don't be like worried about those. In a lot of the examples you do, they won't even have those. Sorry, I know it was exciting. So you do that, and now you're like, okay, my magnesiums match, but my oxygens don't match, so we've got to account for that. So we're going to go and say, like, okay, how do I fix this? Well, I need 2 oxygens here. Sure. Now remember, I told you can put stuff in front of the compounds only. You can never put anything in the middle or end, actually, or at the end. So, like, no. You can never add subscripts. You can never add little things in the middle. You can only put coefficients, big numbers, in front of the elements or the compounds. So in this case, we need 2 oxygens. So we have to put a 2 here. Now, that obviously will mess with magnesium also. So you're going to be like, okay, I have 2 oxygens, but I have 2 magnesiums now. Okay, great, whatever. So then you just go and you're like, okay, like now the oxygens are good. Yay. Then you're like, wait a minute. What about over here, the magnesium? I have 1 magnesium, I need 2. So then you're like, oh, I put a 2 there. That changes this to 2. Now, you can leave these blank. Like, if nothing's written there, assume it's 1. You don't need to put something there. Just assume it's 1. But, just here for the sake of questions, you can just leave it as 1. And that's good. And then you're like, oh, okay, everything matches. The 2 things match. Now, to be clear, your answer, this is your answer. The 2 and the 1 and the 2. So it's a ratio of 2 magnesiums to 1 oxygen molecule makes magnesium oxide. It's a cool reaction, actually. When you light this on, this is like basic magnesium burning. It's actually pretty neat. That's a very bright reaction. When we get back into school, I'll show you. So You do this, and you're like, all right, that's it, you're done. But again, this is the answer. This stuff down here is just to help you solve. At least that's how I envision it and how I use it. Here's another example that we'll go through. Again, I have these all worked out, but just for the sake of showing you this. So, and again, these are all done in the video. So here we've got like zinc, H, and Cl. Oh, pen's running out of ink. That's horrible. It's not good. So what I did in this case, we got zinc, we got H, we got Cl. We've got one of each. Over here we've got zinc, we've got H, and we got Cl. Something that I suggest you do if you're writing these out, make sure that you keep them in order. You know, keep them in order here, like this. Even though it's different over here, just keep it in order. So we've got one zinc, two H's, two Cl's. So like, all right, zincs are already good. So that might change depending on what we have to do. Then you look and you're like, oh, I got two H's, two Cl's. Over here, I got one and one. Oh, look, there's HCl. Put a 2 there. That gives you, and all of a sudden, everything's good. And you're like, oh, cool. So there you go. Sometimes these are really simple. You're done there. And you would just put 1s for everything else if you felt the need. Now, to finish the rest of these, watch the video linked in the notes, please. And you can skip the first couple examples and get to the more complicated stuff, because there's definitely more complicated stuff. And then, yeah. Now, once you've done all that, your homework is going to be to just go through and try to do this page. All right, so your homework is going to be, again, once you have watched the videos linked here, all right, they're linked. It's linked in the description, and it's also linked on Canvas. All right, once you've watched this video, seen the more complex examples, you're going to go and you're going to try to do these 20 problems. Sounds like a lot. It's really not that bad. You should be fine. Some of these are harder than others. Some of these are definitely harder than others. But then some of these are like crazy easy. Some of them are already balanced. All right. And yeah, like, so the videos show you how to do polyatomic ions. That's important. Some of these are directly from the videos. So you should be all right. And then we will go over this, and we will do a bunch more stuff on this on Monday of next week. All right. Let me know if you have questions.